Okay, today is May 20th at 9:07 here. You can see it. And what we're going to do today is we're going to demonstrate something called a Hydrautomat, a miniature version of what I used to have. And for those who don't know what this device is, it is a self-powered water pump that uses the difference in elevation, exploits that in combination with air and water pressure to actually lift water upwards. So what I'm going to do is probably explain what this all is right here. So let's see, just want to show you. What will happen is that we're going to have this large mass of water here. It's been dyed with blue food dye. Hold on a second, I'm going to flip the screen here so you can see what I'm doing. And what's going to happen is I'm going to have this water flow down through this tube here, and it's going to come out through this little bulkhead fitting here in the bottom of this tank. And what's going to happen is it's going to rise up, and then what will happen is that we will actually fill this thing up to the point that it goes through the siphon, because there's also another bulkhead fitting here in the bottom. And what will happen is that this water will fill up through the siphon and eventually go over the top right here. And just kind of pull the siphon out of the condensation pump. And when it does that, it'll start to drain out. And then at that point, when this thing starts to really drain, and we don't have any more air pockets in here, because that tends to happen, what we'll do is we'll cut this off. Like it is right now, it's actually turned off. So what will happen is the water from here can't replenish the water in here. But this will keep on draining out through the siphon. So what will happen then is that this thing will keep on draining, nothing will be able to replenish it, and it'll create a partial vacuum with the amount of air that's left in here. So what happens is as the water goes down, it also pulls the air down with it. And attached to this tank here, through this air tube, going up through here to the top of this tank, what will happen is it'll also pull the air out of this tank here. So this right here will create a vacuum that'll then transfer into this tank here, which will also have a vacuum develop in it as well. Now what that vacuum will do is it will actually pull the water from here up into this tank. That's what this thing will actually do. So when this thing starts to drain out, what happens is the vacuum here will start to pull on through this tube right here. It'll start to pull on this water and actually suck it up through this tube into here, and it'll actually deposit into this tank. Then what will happen is when this is fully drained out, what we'll do is we'll turn off the siphon, open this up again, and what will happen is that this will fill up again, right? But instead of having a vacuum, what will happen is we'll have a positive pressure, so the air is going to be pushed up. Alright, so all the air in this tank here will end up being pushed up and into this tank, through this little air tube here at the top. And what will happen then is that the air will actually push down on the water. And when it pushes down, since we have some check valves on here, what will happen is they'll push down on this tank and go out through this other tube in the bottom of the tank. There's two openings here. The second one's for the outlet here. Go past this check valve, and then what I'll do is I'll push the water from here up into here. Alright, that's what this one will do. So basically, because of the drop from this tank here to this tank here, we're actually able, by the force of gravity, to push air up into this thing and then push the water out. And because of the suction that results from the draining of the siphon from this point here to this point here, all the force of the water pulling down will actually cause the water to be pulled from this tank up into this tank on a suction cycle. So what we're going to do now is going to open this up right here. I'm going to zoom in on this so you can see. So this is draining out. This is filling up. Provided it can, hold on a second. So as you can see right there, as soon as it's filling up, right there. And what's going to happen is it's going to eventually go through the siphon here. I have the siphon turned off right now. As you can see, that valve is closed, so I'm going to open that up. And we're going to see this thing actually start to open up. Apologize for the way the video is done. Fortunately, I can't encompass the entire hydrotomat without these tubes appearing very small in the video. So, do what you can. Alright, so now what we're going to do is we're going to open this up right here. Alright, so now the siphon's filling it through. There's no, spoke too soon, there are little air pockets. Alright, just a few air bubbles. Now what we're going to do, we're going to turn that off, going to leave the siphon on. Okay, and now what you're going to see right here, see that wire? See it flowing up there? Unfortunately, this stupid thing doesn't want to focus. Okay, I have no idea why, but it's working. Hold on a second. I'm going to have to detach this camera here. That's a condensation pump, by the way, because instead of water going from this operating tank here onto the floor, what happens is I have a condensation pump and just pump it back to the feed tank, keep it from going on my basement floor. So anyway, we have this thing filling up. As you can see, it's starting to fill up here. So it's coming up through this tube here, and it's slowly starting to fill up the tank. I'm going to get around here and show you. As you can see it there, that little waterfall, it's like right here. It's filling up. The tank is slowly filling up right there. And what will happen is this process will continue so long as there's enough suction being generated from this tank draining out through the siphon here. As long as this water keeps draining out from here, it's going to keep on making more and more negative pressure, and that negative pressure, which I think I can get this at an angle to show you how it's bowing, how it's contracting. There's actually kind of a curve shape, you know, it's kind of curved like this. It's kind of coming like this here, and it's bowing like that. This is actually under vacuum right now, partial vacuum, and that vacuum is transferring up into here, which is slowly pulling it up. As you can see, unfortunately, can't really see that. I can kind of show you how it's dripping now. Okay, yes, because what happens is mainly running down the side of the tank there. So anyway, this device is now filling up slowly. So the water from here is now being raised up through, I think, yeah, this tube. Water's being raised up through this tube, okay, up through here, past my ruptured check valve. Oh, no, this one's ruptured too, by the way. This is also ruptured, so I put this hose clamp on it because this check valve broke. So anyway, water's coming up through here into this. Keep running that hose there, and it's starting to fill it up slowly. So as you can see now, it's nearly a half gallon full. I mean, this whole container contains about a half a gallon of water, and it's like 3/4 of the way full almost. So that's what it's doing right now. And this thing's slowly draining out, as you can see. And this thing's coming toward the end as it slowly drains out. The reason why it's not draining out like it would normally would take, because, you know, it doesn't take much for this thing to drain through this pipe, right? Well, you got to consider the fact that this is actually a vacuum, so the vacuum that it's generating is also fighting back. So it's pulling this way, but there's only a certain amount of air in here. So it's actually, the vacuum is also pulling up on the water, as well as the water trying to pull down. It's a bit of a tug of war that's going on right now in this tank. So what will happen is that you see this little black bulkhead here. That's what this siphon is connected to, is through this port, and this intake here is connected to this little white gray bulkhead right here. So what will happen is this will slowly get down to the edge of this right here, and when it comes down, yeah, it's really draining quick, man. But what will happen is that when this thing fully drains out, what will happen is that the air will actually get sucked in through this tube here, and it'll actually disable the siphon. It's going to go right now. It's going to go anytime now. Just watch. There it goes right there. This is cool. Watch that. And just destroy the siphon. Siphon is now disconnected, This is all filled with water, I mean air. And the pressure, I think, has been kind of disabled. No. As you can see, there's, yeah, see this? That's water right there. I gotta put more food dye in it. But as you can see right here, there's still, there's kind of like a pressure or something. I don't know what the hell. But yeah. So the water is actually being sucked up through the siphon right now. Higher than where the water line is. Right here. It's kind of interesting. So anyway, I think what happened was this is kind of pushing down, or something's going on. Anyway, this thing has now been pretty much filled to its capacity. Alright, so far as this one goes, so this has been fully drained out. The water from here has been pulled up into here. Okay, so now what we're going to do is we're going to disconnect the siphon, because what will happen is otherwise, if we turn this thing, if we turn this on right here, the impulse, the kind of, I won't say so much the shock wave, but it kind of is, the rapid amount of force that would come from here going into here, what that would do usually is that pushes the air up, that pushes the water up through here so rapidly that it'll inadvertently, prematurely trigger the siphon before you want it to trigger the siphon. So before this thing's even full, the siphon will start draining. So what we're going to do now is we're going to disconnect the siphon right here, so it's turned off. Going to get rid of any vacuum that's left in here by opening up the air tube right here. So I have this little bleed off valve. You hear that crack? Yeah, watch. See the air? It's going to come out through here. Okay, just push the air down through this here. So this is actually filled with air, this tube. Oh, there we go. See that? Wild, huh? So this is all atmospheric pressure, and now the water is actually sinking down back to this water line here, because now this thing has been restored, is starting to restore toward atmospheric pressure, and the water is just starting to sink back down through this ruptured check valve. As you can see, the check valve is ruptured because it should not be going backward if this was operational. Stick it in the MasterCard check valve. But anyway, this thing will pretty much stop around this water line here. So, you know, a little fun fact there. This is all filled with air now. But anyway, so what we're going to do now is we're going to close this back up again so a pressure can build up in it. Otherwise, all the air is going to be pushed out through this tube here. So I'm going to expertly one-handed close that right there. This has all been closed off. Okay. I prefer to use gas tape, by the way. If you notice why that's yellow, I use gas tape rather than normal pipe tape. So we're going to open this up, and what will happen is this area right here is going to be pushed up by the force of the water, okay, and also the air can't go out through the siphon anymore because it's been closed off too. So the water here is going to come from here, flow down up through here, and it's going to push the air up that tube again, up this tube. Where is it? Oh, right. Up this air tube right here, okay, and the air pressure is going to push down right here, and it's going to push the water up into this container here through, I think this tube has been connected. Now there's one problem, and that's because in order to get this thing to work I had to close this off manually because the check valve also blew out in this one. So I'm going to pause the video, and what we're going to do is I'm just going to take this check valve off, and I'm just going to switch it onto this tube. So I'm going to pause it. Okay, so we're back. Actually, as I said before, we changed things up a bit. So this used to have the hose clamp on it to close it off, and this right here now has the hose clamp on it to keep the water from going backwards. Okay, so we have that all rigged properly to work, and I think I'm going to have to manhandle this camera just to give you a bird's eye view, but a closer view of what we're going to do. So we're going to open this up, okay. Now this is filling up slowly. Might not be able to see it right away, but yeah, it's filling up more and more. Okay, and as that fills up, what's happening is the water has already started to pour over. So, and right now it's actually pushing the water down slowly out through this tube right here. As you can see, it's coming through. Fortunately, I have this stupid air pocket again. There we go. Hold on a sec. I have to tweak it a little bit. Here we go. Try and get this blasted air pocket out of the tube. Come on, you. There we go. Okay, so it's now, that's been solved. And now you can see a better version than you could with the suction phase, because it was too close to the wall for you to see it properly. That's why it's fighting so much to try and get you to see it. And now, as you can see on the pressure phase, this thing's just dripping down right here into this, like so. And it's just slowly filling up. So that's what we're doing right now, is it's filling up. It's pressure phase. I'm going to try and put this back on a tripod. It's a little more stable. And we're going to zoom in. Now, I don't know if I'm going to have an extended video yet, or just going to have a short video to cut two things. Actually, I'm going to put an annotation on this video, so if you want, you can probably skip ahead and see this whole thing filled up. But basically what's going to happen is that the operating tank's going to fill up, it's going to push the air back into this tank here, and it's going to push this water out through here. And it's just going to deposit in the bottom of this higher tank that's being hung from the top of the shelf by means of clothesline wire, which is steel wire. So as you can see right there, that's happening. And actually, so even though this right here is open, as you can see that valve is open there, even though it's open, this tank is actually not filling up very quickly, and that's because there's a pressure, right? So the tank here on the tank tank that's above the operating tank. So this here's the operating tank. That large open tank that I had is the feed tank, and the one that you saw before being with the suction cycle here. I'm going to show you. So this right here is the operating tank, which is basically the water, basically a pneumatic piston, a piston that runs on water. That's what this tank right here is. This tank is a feed tank because it feeds the water into the operating tank. This is the first stage and this is the second stage, right? So anyway, the operating tank right now is slowly filling up. The water is resisting against the air. I mean, the air is resisting against the water. Okay? And as it's slowly starting to win that little tug of war, because the water is water pressure is being relieved by depositing out through here. As that's happening, this is slowly starting to fill up. And what will happen is this will either stagnate in the tank because there'll be an equilibrium that's found, or what will happen is that this thing will just kind of go to the water level of this thing. And or the third thing that's going to happen is that it's going to pump up so much water into this tank here that it's going to pump water down out through the output tube here. And then what will happen is that since there's no more water in this tube here, all the pressure is going to be forced out of this and it'll be restored to atmospheric pressure or something close to it. So that's usually the three most likely outcomes to happen with this operation, this current phase, which I call the pressure phase right now. So as you can see, this thing is slowly draining out, this is slowly filling up, and the operating tank is slowly filling up. Now, some people say it even runs on blue water and magic, which I got that a few times at the Harvey poster session at the college, which was fun to say at least. But it doesn't run on magic and it's not perpetual, because I'm going to show you exactly why right here. It lies with this little tank, all right, as well as the siphon. Because what happens is all the water that goes into this tank goes out on the ground through this siphon here, unless of course it gets pumped, which it's not over Unity whatsoever. So some people say it's a perpetual motion device in the modern day. Some people even said that back in the 1920s, like 1921, when this thing actually debuted. So anyway, this is not over Unity. All the water that goes into here goes out on the ground, while part of the water, okay, that goes into the feed tank, part of that water from the feed tank here gets sucked up into here. So it's kind of 50-50, I guess. It all depends. Because it's not necessarily 50-50. It really depends. All the pressure and suction. I think I said this before, but just in case I cut the clip out. All the pressure and suction cycles, typically, by the rule of thumb for me, is that the pressure is largely determined by the height, by the difference in height or whatever from the water in the feed tank down to the operating tank, right? So the fall from the water in the feed tank going down to the operating tank really determines your pressure, and the fall from the water in the operating tank down to the end of the siphon, wherever that end is, don't even need a condensation pump, you just keep that thing going forever, that determines your suction. Alright, and then the volume of the tank determines how much can be sucked or pushed in one stroke. Now, I have no experience in pneumatics other than this stuff here. I have no formal training or anything like that, so correct me if I'm wrong. I'm just a backyard inventor / engineering student, and I just took my intro course, which give you a little perspective. I don't know what the actual fluid dynamics laws are, but that's pretty much what you need to know in order to get this thing off the ground in order to work. And I've pretty much perfected the design. I mean, I got this thing built in like 2 or 3 days. So if you want to build this thing, you don't need a lot of experience. You don't need to be an engineer. You don't need to have any formal training. This thing is very easy to make. The reason why I'm saying this is that if anybody wants to build this device, it's very easy to do. Just need to work at it a little bit. So yeah, I hope you like watching this video. Let me know what you think. And stay tuned.